Okay, so keeping with our common theme on induction, let's assume that 1 plus 1 over 1, 1 plus 1 over 2, dot 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 dot, plus 1 over n, 1 over k is equal to k plus 1, and then we'll move into the k plus 1 step and hope that we can figure it out. Okay, notice that 1 plus 1 over 1 all the way up to 1 plus 1 over k times 1 plus 1 over k plus 1. So again, I'm not assuming this is equal to anything. I'm kind of hoping that it's going to be equal to something that I want to find, but we're going to try to work and see that. But I do know from the induction hypothesis that this part is equal to k plus 1. So that's k plus 1 multiplied by 1 plus 1 over k plus 1. So if I distribute, I then get k plus 1 plus k plus 1 over k plus 1, of course, is 1. So we get k plus 1 over 1. And notice that that is precisely this statement with a k, but now replaced with a k plus 1. So that is the inductive step. You still have to do steps 1, 2, and 4 in your homeworks and on the assessment, but that gives us the inductive step. Okay, write the first 6 terms of this sequence, in which the first term is 2, and then the next term is defined by the last term minus a sub n. Okay, fine. a1 equals 2. a sub 2 is equal to 2 times, okay, since n would be equal to 1 to find a sub 2, that means I need to 2 times 1 minus the previous term. So that would be 2. 2 minus 2 is 0. a sub 3 would mean to take 2 times the previous number, which is 2, minus the previous term, which is 0. 4 minus 0 is 4. a sub 4 means to take 2 times the previous number, subscript, minus the previous term, which is 4. 6 minus 4 is 2. And a sub 5 is equal to 2 times the previous term, the previous number minus the previous term. 8 minus 2 is 6. And then a sub 6, the first 6 terms, yep, last one finally. 2 times 5 minus the previous term, which is 6, which brings 10 minus 6, which is 4. So 204264 is this sequence. Find the 30th term and the sum of the first 30 terms of this sequence. So it definitely looks like we're plussing 5, right? Add 5, add 5, add 5, add 5. So the 30th term, we know that a sub n would be equal to the first term plus n minus 1 times the common difference. So the 30th term would be equal to 3 plus 29 times 5. 3 plus 29 times 5 is 148. So that finishes the 30th term. To find the sum of the first 30 terms, we would take n over 2 times the first term, which is 3, plus the 30th term, which is 148. So we need 15 times 151, and 15 times 151 is 2265. 2265. So that appears to be the final answer there. And then finding the 8th term and the sum of the first 8 terms of this sequence, this appears to be geometric, right? So the nth term would be equal to the first term times the common ratio to the n minus 1. So in this context, the 8th term would be equal to the first term times the common ratio, which appears to be a doubling, right? That's what you get from 1/8 to 1/4. The doubling to the 8 minus 1, which would be a 7. 2 to the 7th power is 128. So again, 128 divided by 8, and 128 divided by 8 is, that was 16, right? Yeah, 16. So it looks like the 8th term would be 16. We could also just write these out, right? It would be 1, and then we have to go for more, so 2, 4, 8, 16. Yeah, perfect, 16. And then the sum of the first 8 terms would be, a1, the first term, 1/8, times 1 minus the common ratio, which is a 2, and we want 8 terms, all over 1 minus the common ratio, which is a 2. So we end up getting a 1/8 times, let's see, 1 minus 2 to the 8th. So the 2 to the 8th is the 256. So 1 minus 256 is negative 255 over 1 minus 2, which is negative 1. Oh, so it looks like we're getting an answer of negative 255 over 8. Actually, positive 255 over 8 because a negative divided by a negative. So I think the answer is 255 over 8.